All right, settle down. What an awesome introduction. Now, I'm super excited to be here, and this is my excited look. When I look around, I see a lot of familiar faces as well as a couple of new ones. To all of you, welcome to Escape 2018. Before we start, there's something I'd like to share with you. Escape has definitely become a major event in our calendar where we all get together and celebrate the things that keep us excited, technology. Now, this year, Escape is celebrating, or we are celebrating 5 successful years of running Escape, and I think that deserves a hand. Now, we've had the pleasure of hosting some of the biggest names in the industry on this very stage. I remember Aki Anastasio, a radio personality and all-round technology enthusiast who brought us innovations of the 21st century. Richard Mulholland, a bike-riding, punk-rocking, intellectual gentleman who brought us Legacy Tequila of innovation, as well as Vusi Tembakwayo, world-renowned speaker, entrepreneur, and venture capitalist who brought us vibrating Dorothy panties. When it comes to big names, we've done well. These names have opened Escape with the fanfare that it deserves. And this year, things are no different. We are fortunate because today's speaker has got a striking resemblance to Mel Gibson, especially after the fight scene in Lethal Weapon 1. So put your hands together and please help me welcome to the stage a guy that is extremely effective behind the scenes, Mr. Tony van der Linden. Yes. Today is the first time I'm willingly taking the stage, and seeing that everybody's inside and the doors have already been locked, you are now all forced to listen to me. But don't stress. We are going to have some fun. So why are we here? I'd like to share with you something that is probably the most talked about topic in the industry. We have arrived. We have arrived at the point in time where everything is done and everything is excellent. We are stoked because absolutely everything is reaching perfection. When we look into what we have achieved, we see that we have indeed conquered industry. We're excited because science fiction is becoming science fact. The Internet of Things is becoming the Internet of everything. We are at the center of digitization, mobilization, augmentation, disintermediation, automation. In fact, most things that ends with Asian are surrounding us. We are so proud, we've even coined a name for it. Yes. Today, I'd like to talk to you about the Industrial Revolution 4.0, a term that represents the biggest revolution mankind has ever seen. But where does this all come from? I remember learning about the Industrial Revolution when I was at school. I don't know why I decided to take history as a subject or why we were forced to learn about this. It was a very confusing time for me. Anyway. We learned that roughly between 1760 and 1820, machine tools and factory systems were born, like you could give birth to a steam-powered hammer. It was very revolutionary and quite disruptive, especially for small family-owned metal shops and blacksmiths who eventually found themselves working in these factories to make ends meet. It's also worth noting that this all started in Britain. The Industrial Revolution really put Britain on a map. They were previously only known for warm beer and mud, very much like today. Now, thank you, Rory. This is what I remember, this is what we learned. But now, apparently between 1870 and 1914, the start of World War I remember that because I had to learn that too, the second Industrial Revolution occurred. Apparently steam power was not enough, and as electricity was the new thing, all these factories were upgraded, and this really changed things. The power of electricity enabled mass production, and suddenly, we were able to make things faster than ever before. There are also a couple of innovations during this period, like the internal combustion engine and the telephone, but this is the era that brought fame to Henry Ford, who introduced something that is definitely the biggest and most notable change during this period, and this was the assembly line. Now, roughly around 1950, nobody really knows, another industrial revolution occurred. Microprocessors and computers were the new thing, and once again, all these factories were upgraded with robots in an attempt to automate factory systems. Robots were way stronger than humans. They could work 24 hours a day and did not complain as much. So out with humans, in with the robots. It's strange because when I look at modern factories, I'll still see a lot of humans around. Now finally, and the reason that we are all so excited, today we have arrived at the fourth industrial revolution. We cannot stop talking about it. We're excited because we've got things like cloud computing, AI, machine learning, digital twins, smart places, cyber-physical production systems, and the list goes on and on. And we believe that these innovations have such an impact on humanity, we must be experiencing a revolution. Now, this is also exactly why I get confused. I know all about the first one because I was forced to learn all about it. Ritalin wasn't available when I grew up, but I'm sure I would have remembered something about the second or the third. So I did some research. I went to my favorite dictionaries. Went to go see if there was a definition that catered for all four of these occurrences. The first one said, Industrial revolution is a change resulting from moving from hand tools to machines and the development of large-scale industrial production. Now, this cannot be it. When you think about it, it sounds very much like the first one. In fact, most definitions painted the same picture, except for the next one. It said, Industrial revolution is finishing a six-pack of 500 milliliter steel reserve malt beer by yourself in one night. Now, this one I could relate to. We could not find steel reserve, but on a recent trip to Bloemfontein, Rory attempted an industrial revolution. Yes, but he passed out. But he felt when he passed out next to the toilet after tequila number 9. True story. So it was obvious I was not going to find an answer looking at the Industrial Revolution. So I turned to revolution alone and found that revolution is the violent and necessary transition from one system of production to the next. Now this started to make sense. When you think about it, there was a necessity to move from hand tools to machines. This formed industrialization. There was also a necessity to move from steam power to electricity. This enabled mass production, and the same can be said for moving towards automated production lines. However, when I think about them, none of them were violent. And when I say violent, I don't mean blood and guts violence. I mean drastic, radical, or extreme. So this description does not work for all of them. I finally found the following. It said, revolution is a sudden, complete, or marked change in something. Now this is it. It works for all of them. Marked change. Steam power, electrical power, computing power, cloud power. If there's something that we've learned to do really well, it is selling our bullshit. There's nothing sudden on what we're talking about here. There's not been some high-profile event with some famous guy in a big key going, "Are you tech guys ready? I'm about to turn a key." Or, "Come on, machine learning. This algorithm was supposed to be checked in months ago. Just get it and we'll fix it in production." No. So why am I calling bullshit? Let me show you something. This represents my family tree, or at least a part thereof, and that's my son. What an awesome little dude. For those of you that have met him, you can testify that he's a well-mannered and polite little man. Yes? Thank you. He loves sports, especially swimming, and he's actually quite good at this, but this guy does not do structure at all. Let's put him on the tree. Next. That's me. I know as some of you are thinking, if I moved my butt off the seat, I would have been able to drop my knee, meaning I could have taken that corner way faster. Doesn't matter. Most of you know me. I love bikes, I love speed, I love adventure, and I'm a little bit of a geek. I do well with structure, but believe I do as well without it. So let's put me on the tree, right there. Now, that's my father, and he used to be a draftsman. This guy loves straight lines. Everything has to be square, everything has to be level. My dad loves fishing. I hate it. I like change. He cannot stand it. In fact, this guy has been driving the same old car for as long as I can remember, for 2 reasons. He doesn't like change, and he's extremely stingy because he's Dutch. You may not know this, but if you go to any Dutch recipe, it will start off with borrow an egg. Let's put my dad right there. Next, this is my grandfather. And he used to be a factory steel worker who gave up everything, packed up his family, and moved to South Africa to become a farmer. There's nothing my grandfather liked more than working his fields all day. This guy was huge, as opposed to my dad, who's quite a bit shorter than me. My grandfather had these big hands, and I got told that my father failed standard 1, or grade 3 to you younger guys, because my grandfather slapped his teacher. Why? Because the teacher said my dad could not speak Dutch. And this was just after they moved to South Africa, and I think my grandfather felt a little bit insulted. I also think that this had an influence on the relationship, because a couple of years later, my grandfather sent my dad to the shops. And while he was away, my grandfather packed up the whole family and moved back to Holland. I can actually still imagine him coming back saying, "Where are you guys? I got the egg you asked me to go and borrow." Anyway, let's put him right there. Now, finally, this is my great-grandfather. This guy was apparently as mad as a box full of frogs. He lived in a castle in northern Holland and was famous for waking up at 4 o'clock every morning, going outside in his white pajamas, and waking up the village with his bugle. Sure, you're right. Let's put him right at the top. So why am I telling you all this? What do we all have in common? Nothing. Except we all share the same name. There's no similarity between any of the Anthonys in my family, yet we all have the same name. And we see this exact same thing happening in our industry. We are awesome at repurposing words regardless of the concepts they stood for. Let me say it again. We are awesome at repurposing words regardless of the concepts they stood for. Let me give you an example. Software crisis. We love using this word, and we use software crisis for absolutely everything. A method doesn't work for us, so we adopt another one. Why? Well, to avoid software crisis, of course. We use software crisis to scare people into believing us, and we use it to predict doom and gloom. But did you know that prior to the mid to late 1960s, software was constructed by engineers and mathematicians, these guys. And they used strict engineering principles. Now, this made sense because most things were hardware-related anyway. But as things change, and they do, software moved away from these strict principles and adopted something we know very well. Code and fix. Chaos. Code and fix. Now, the code and fix approach was favored because software was supposedly easier to modify than hardware and did not need these strict principles. But with this new ability to productionize software a little bit faster, demand increased. And suddenly, there was a shortage of skilled programmers to meet this new demand. It's a big problem. Not enough people to do all the work. Sounds familiar, right? Now, this is a job ad that was posted in January 1965 with large red friendly letters saying, "Wanted, 500,000 men to feed computers." These guys went all out. The selling line was, "You don't have to be a college man to get a good job in computer programming." And at the bottom, they had 4 points that summarized the daily activity of a program. They're inconsequential because it talks about punch cards and looking up instructions in a special dictionary, but I love the first one. The first one says, from his boss, a systems analyst, the programmer receives his assignment. So you guys have been here since the start, and this proves that you can tell this what to do. They even went as far as publishing guides like this one, Your Career in Computer Programming. This was a complete guide telling you absolutely everything you needed to know to become a programmer. It's crazy. I love this book. It is inaptly named The Computer Boys Take Over. But I'll explain a little bit later why I say inaptly. Now, this book tells the history of software engineering and notes that on 5 November 1966, Business Week published what is said to be the first publicized use of the term software crisis. The article is not about poor quality or late delivery or software development projects being over time. The use of the term software crisis was to highlight the shortages of skilled developers in the industry. See how I get so excited when we start talking about software crisis. So I believe industrial revolution as a term has been reappropriated to secure focus. Why? The fact is that the debate about the second industrial revolution is actually still carrying on. I read the other day that there was a movement to renumber all 4 of these occurrences to include medieval technologies from the 12th century, ancient Chinese technology from the Tang dynasty, and even ancient Roman technology. But the fact is, industrial revolution as a term has been used by popular press, technologists, and industrialists to refer to any technological advancement since World War I. Okay, who knows who that is? No, it's not not my grandfather. Let me give you a hint. Okay. His name starts with T.S. and ends with Eliot. Ah. He was one of the 20th century's most famous poets, and he once said, "The historical sense involves a perception, not only of the pastness of the past, but of its presence." Now, what does that mean? In short, our future is defined by our current actions as well as our learnings from the past. And this is interesting because herein lies my second reason. When the first industrial revolution occurred, nobody said, "Are you having a fruitful industrial revolution?" Or, "This revolution has been tough on my family. I've lost 2 children to the factories. Hope the next one will be easier." No. It's only years later that some old guy coined the phrase in explaining industrialization in Britain. Next 2 did not even feature. Why? They were not radical. They were evolutionary. But yet, we believe that we've got enough evidence to predict a revolution that will have the first one running scared. Here's another one. You won't believe this, but the robots have not replaced us. Well, not yet. And when they do, it wouldn't matter because robots are great at simulating, but not at being. It is all about perspective. What is perspective? Perspective is a particular way of thinking about something. And I say particular because it's very much influenced by our beliefs and experiences. The hype that is created around Industrial Revolution 4.0 is affecting our beliefs. It is providing a foundation. And then we see the cool stuff happening around us. And this is fueling our experience. And all that we are left with is a perspective of a life-changing event, a revolution, if you will. But unfortunately, this reduces our ability to focus on what's actually happening. Do you want to know what that is? Yes. Are you sure? Good old-fashioned change. We've long been in an environment of continuous change because something changes that allows something else to change that allows something else to change. It is not a revolution, it is evolution. So what is the hype all about? During the rest of my talk, I'm going to share with you 3 facts. At least one of them is a little bit like plumber's butt. Once you've seen it, it cannot be unseen. But in order for me to land the first one, there's something I have to explain first. So just bear with me for a moment. Everybody loves graphs. And of all the graphs I've drawn in my life, this one is my favorite. Coincidentally, this one is also very relevant to what we're talking about today, the old S-curve. But this is not just any S-curve. This is the innovation S-curve, or the technology life cycle. And it's got 4 stages. The first stage is the era of ferment. This stage represents innovation or research and development. The product is completely new. But as time goes by, we eventually reach the takeoff stage. And this is where all major technical problems have been resolved, and we are able to meet the demand in the market. We have a dominant design, and we have secured the product, because even the early majority is adopting it. Now, this is where things get interesting. The red line represents expectation. If you look at the graph, there is an area where our expectation is not aligned with what the product can offer it. And I call this the area of disappointment. We're disappointed because there's a mismatch between what we want and what the product can actually do. But eventually, these lines meet up. And unless you are an early adopter, everybody knows that the buying moment is where expectation meets reality, or what we want can be satisfied with what the product can offer. And I call this the iPhone moment. Who has not owned an iPhone before? You guys won't have a clue what I'm on about. I'll try and explain it as best I can. Now, the iPhone moment is exactly that point in time where the stars align and you realize this is the one you've been waiting for. Like the day you employed me, right? When I think back to my first iPhone, and I've had absolutely every single one of them, except for 8 because I jumped straight to 10, I remember almost buying a Samsung, who just a couple of months before the release of the iPhone released their first touchscreen device, the Samsung SGHT 919. I did not like this phone. Clunky software, and the touchscreen was not working as well as I expected it. I think even Samsung knew this wasn't a great phone, hence the model number of the phone. Thankfully, Jobs came to the party and just a couple of months later released the iPhone, a phone way superior than anything the market has ever seen before. Quality software, great user interface, and it came in a metal casing, a buying moment to me. But let's get back to our graph. Next, we reached the maturity stage. And this is where everybody has adopted the product, but it's becoming obvious that we are reaching the product's physical limitations. So we turn to standardization to low cost in order to keep control of the market. But eventually, we reach the discontinuity stage. And this stage marks the birth of new innovation. It's an opportunity for a new product to appeal to the early adopters of the population. This is also, unfortunately, where most explanations of the technology life cycle ends, because what happens next is probably more important, and that is disruption. During the sunset years of the product, the competition was working on a more superior product, and the discontinuity stage is typically where disruption happens. When we look at what's happening in the, but like the first product, eventually the second and third will also be replaced, and this we call evolution. Now, evolution is something we know, and we're happy with it. Why? Well, because it's linear, gradual change over time. There are times that our expectations are not being met, and this is annoying, but the fact that change is gradual gives us time to accept it. When we look at what's happening in the industry today, we see that change is starting to occur earlier and more often, because something changes, that allows something else to change, that allows something else to change. But this time, our expectations are not able to keep up. It is disruptive. It is disruptive because we are not used to this pace. There's a major threat that I believe we need to acknowledge, and this is our ability to change. Why do I say that? Technology does not disrupt technology. Technology disrupts people, especially those that are not ready for it. Quick quiz. Who can tell me the name of the first computer? Let's see some hands. I know you know, Rui. Okay, Rui. ENIAC. Electronic numerical integrator and computer. Yes? Wrong. It was actually Dorothy. Let's have a look at this.
Temporarily, yes. We need the IBM for when it's launched. But the enhances fit with cost, programming, and such.
What about the rest here?
When human computers can't calculate and walk the flat in the time we have. Does he go for now?
What about after that?
After Glenn's launch, masses dissolving competing groups.
I said you inside. Unless I got anything.
Excuse me?
Then log in how programming these. I can't do it alone. My guys are ready. They can do the work.
This is one of my favorite movies, Hidden Figures. If you have not seen it, do yourself a favor. This movie will blow your mind. Now, Hidden Figures tells the story of 3 females who worked at NASA on Project Mercury during the space race. In the middle is Katherine Johnson, who was a mathematician who manually calculated flight paths. Imagine doing that. On the left, Mary Jackson, who eventually ended up being NASA's very first black female engineer. And then the lady in green, Dorothy Vaughan, who was a computer supervisor at NASA. Now, Dorothy realized that if they don't adapt, they will be replaced by machines. Now, I promised earlier that I'll get back to this point. I said, inaptly named the computer boys take over. And I said inaptly because the very first incarnation of programmers were actually women. They were previously referred to as human computers until they were disrupted by machines. Now, Dorothy's proactiveness allowed these women to beat disruption and become computer programmers. Here's a moral to this story. Dorothy did not sit down to wait to see what was going to happen to these big machines. No. She made sure that she was ready for when they happened. And I believe that we are finding ourselves in a similar situation than the one Dorothy found herself in. Are you ready for fact number one? Well, hold on to your seats because here it comes. We are being disrupted. Yes, we are being disrupted, and to help me explain my point, please welcome to the stage a man whose personality and capabilities are the only things greater than his height, our own Kouwersdorp, Mr. Rory Preddy.
So when Tony told me that my topic was we are being disrupted, I told him, I'm sorry, and I'll try to stop annoying the people around me. The last time this happened, they turned my chair away from the corridor, and I'm now facing the window. He said, no, BBD is being disrupted by an external force. I think I understand. BBD has always delivered. Sometimes deadlines are tight, and heroes walk a tightrope, all the time balancing our clients' expectations. You all know the quote, if I have not seen as far as others, it's because clients were standing on my shoulders. We have fine-tuned our delivery design patterns. We do our thing, business as usual. I remember standing in a queue at Macro and having attention span of a goldfish. Well, anyway, that's been unkind to goldfish. Well, anyway, I asked the person what he was buying, and he told me, a printer for his social media analytics service. For 400 Rand, he could give me a report on our social presence and also our competitors. My jaw dropped. You see, we already had an entire team at BBD who was offering the same service, but at a much higher premium. You see, the ease of access of social media APIs disrupted one of our unique business processes. Like before, we are being disrupted again. There's a storm coming, Mr. Wayne. You and your friends better batten down the hatches, because when it hits, you're all going to wonder how you ever thought you could live so large. In 2018, AWS CloudFront and Azure ExpressRoute, both local CDNs, landed. In 2019, Azure Compute. In 2020, AWS Compute. We are being disrupted. A CloudFront has brought a storm of change. Business as usual has been disrupted. Our competitors are also in the storm. They are trying to weather it also. But we are being left behind by even our clients, as they build wind turbines and are planning to be cloud ready. How did this happen? Let's first take you back to a story from the golden age of servers. During this time, a company called Knight Capital deployed a new software update to their production servers. One of the technicians missed deploying the new code to one of the 8 servers. Just 45 minutes later, the servers had executed 4 million trades. 2.5 million Rand lost per second for 45 straight minutes. What could have prevented this billion-dollar mistake? 2 simple words: DevOps. I remember loading CDs for a Big Four's internet banking. My colleague accidentally pressed the production power button, and we taped his finger to the power button until we could safely power it down. You see, I was already using DevOps then. But I called it something different. I called it duct tape as a service. I dreamt of a future where DevOps flourished. Automation the primary focus, shorter development cycles leading to faster innovation, reduced human errors, enhanced version control, stable operating environments, quicker mitigation to software defects, a new focus on serverless architectures. Serverless architectures? What's that? We go back again on a journey of server evolution. In the beginning, there was tin. Then we virtualized the tin and stored it on our servers. Some bright spark moved the virtual tin to other people's servers, and we had cloud compute. We upgraded the virtual tin to fit into smaller bits called containers. By the way, did you know that the word Docker actually comes from the definition, a man who stuffs in Spanish? And finally, we got to Homo superior, serverless. Ask yourself, where are you in this picture? Do you have servers to manage? Can you respond quickly to events? Our addiction to servers needs to stop. There are 4 main reasons why you should switch to serverless. It scales with demand automatically. It significantly reduces costs, 70 to 90% because you don't pay for idle. It eliminates server maintenance. It frees up developer resources. We can now focus on doing getting the development done instead of waiting for change control to allocate new servers. I mean, who likes that? I know what you're thinking. Okay, serverless is great, but which cloud provider can I get it from? Choosing a cloud provider has become more difficult. Recently, Gartner announced that AWS, Microsoft Azure, and newly Google Cloud Platform all belong to its cloud leadership quadrant. There are close to 300 unique services between these 3 main cloud providers, each aggressively priced to compete with each other. Whereas the cloud price war seems to have cooled down, each platform is aggressively courting developers. Online coding environments, machine learning, and continuous integration, continuous delivery is all being offered to entice developer adoption. Spoiled for choice? Multi-cloud architectures are where you just don't go with one vendor, but choose several services from a few. Does anyone know what hybrid cloud is? So hybrid cloud is definitely not old IT. Physical servers and virtual machines hosted on-premise on old school servers. The new IT reality is adopting a hybrid cloud approach. It consists of both off-premise and on-premise cloud implementations. So once you have these on-premise and off-premise options, you can use different tactics to design your solutions. You could use off-premise and containers to modernize your virtual machines. Commoditize your applications into software as a service. Connect legacy applications via edge services, or re-architect to cloud-native platform as a service. In June, the South African Reserve Bank recently concluded a project called Project Coca, in which 8 banks tested an Ethereum-based interbank payments platform. Capitec, FirstRand, Standard Bank, and the SARB all use virtual machines from Azure. ABSA used AWS. Nedbank used its own Azure private cloud. Investec connected via edge services. Some hosted with containers, some without. By adopting a multi-cloud hybrid strategy, the project was able to choose best-in-class technologies and services from different cloud providers to create the best possible solution for each business. Gartner predicts there will be 20 billion connected devices by 2020. Hui wee wee, okay, you can also say it, who are we? Predicts 400 million servers by 2020, consuming 20% of the world's electricity. Our challenge to take advantage of this digital revolution is a mindset change. You are not in control. Be comfortable to relinquish control. The terminology can be overwhelming, but think in the abstract. Understand that the physical details have been abstracted away. We have arrived at a golden age of cloud services. We can unlock business agility with machine learning, artificial intelligence, and advanced analytics. Per millisecond build serverless architectures, local data centers around the corner, hybrid cloud architectures, 16 CPU, 16 GPU monster servers, each one 800,000 times faster than the first Cray supercomputer. See digital disruption as a journey that can create opportunities as well as challenges. We are being disrupted, but that doesn't mean we can't be the disruptors. I challenge you to go out there and create a digital disruption strategy, not for anyone else, but for yourself.
Thank you, Rory. Now, I promised you 3 facts. Here's the next one. We at ATC has been fortunate to work in the environments that we do. For those of you that don't know, ATC is pretty much involved in absolutely everything. And this is because of our focus in 3 distinct areas: consulting services, training, and research. Now, this is great because it gives us a view of what is out there and why BBD should not ignore it. Sometimes it's easy to understand, other times it's tough. The next one is unfortunately one of the latter. But with the help of technology and some extremely skilled people, we were able to empirically prove that Rory Pretty is Peter Dinklage. For those of you that are planning to go to Rory's talk this afternoon, you'll see that he spends about 10 minutes trying to convince the audience that he's in fact not. Please do not listen to him. And I say do not entertain his ramblings. He's actually been trying to convince us for years. But to help me share the facts, please welcome to a stage a lady that redefines women in IT, one of our own, Mrs. Jerry Young.
Hello, everybody. Thank you for that lovely introduction, Tony. Before I get to that, I need to explain to you how I got there. So I'm going to start by asking a few questions. Can't really see everyone because it's really dark, but how many people here know what a neural network is? Okay, a few people, that's good, that's expected. We do work for a technology company. What about a convolutional neural network? I can see 2 hands, 3, okay, cool, all right, okay. Who here has ever written a neural network? Rory, I don't think you count, it was only 3 weeks ago. All right, so I wrote a neural network once when I was in varsity. That was a little while ago, but I was proud of it. It was in Java. Rory was proud of me when I told him that. And now I told this to a PhD student who's studying machine learning recently. And he said to me, but that was before 2012. And I said, yes. And he said, oh, but then it doesn't count. So apparently something big happened to neural networks in 2012. I don't know what it is, but it happened. Now, in order to do facial recognition, we require neural networks. Or think it's 2 or 3 or, I don't know, a number of neural networks. So I'm standing in front of you here saying that I'm going to be doing facial recognition, and I don't know anything about neural networks. How are we going to do this? Well, we're going to use the cloud, the Microsoft one to be exact. We're going to use Azure's Computer Vision API. Now, this is an API which abstracts all of the complexities of machine learning away from you, so you can do whatever you want to. And you can write it in a variety of languages: C#, Java, JavaScript, Python. There's a whole lot. I chose C#, and in approximately 200 lines of C# code, I managed to do what I'm going to show you a little bit later. But before I get there, I started the whole tutorial thing, and I was doing the whole thing, and I needed to test it. So I tested it on a photo of myself. And it recognized my human face, so apparently I am human. It said I was female. It said there's 100% chance that I am smiling. I'm not wearing glasses, and I am 27. Now, this part really amazed me, because in that photo, I am 27. And it's difficult for humans to tell how old a person is just by looking at their face. But Azure could tell how old I was. It was amazing. I thought it was the best thing ever. Then I decided to try again. This is where things got a little bit weird. So firstly, it only identified mine and Rory's faces as human faces in the photo. But I have learned not to ask questions I don't want answers to. It did pretty well on the gender and other stuff. I asked Rory if it was okay if I shared the part where it says it's 50 with everyone. He said to me, and I'm quoting, "It's fine because like small children and dogs, computers do not understand dwarfism." So the part that really worried me was that it said that I was 37. Now, this photo was taken in December last year. And I think it got it really wrong for one of three reasons. Each are equally possible. The first, maybe Azure isn't as good as I thought it was. Second, 2 years of marriage had aged me by 10 years. Or third, and this one I find the most plausible, 3 months of working on ATC had aged me by 8 years. But anyway, I thought this was good enough for what I needed it to do, so I thought I should build something useful. I was going to filter our Trello board. Now, that's our Trello board. Please ignore all of the red and the fact that most of the things are assigned to Mike. But I was going to make it filter based on the person standing in front of the computer. In order to do that, I needed some training data. I needed between 3 and 10 photos of each member of ATC. Now, for me, I'm a millennial. I have a ton of photos of myself. But some of you may not know this, but I'm also the only person on the team that doesn't have children. Do you know what photos people with children have? Anyone? Photos of their children, exactly, yes. So finding photos of my team members was not the easiest task. It involved a few trips to marketing to ask for old BBD events, a couple of, "Hey Tony, look over here, I need to take a photo of you," and a little bit of social media stalking. But I got my photos, and I made a thing. I have it over here. This is it. It's currently trained on Rory, me, and Tony. So you can see it recognizes me and Tony, but not Mike. So we're going to go and train it on Mike. And what this process involves is it goes to a folder where there are photos, and it associates the name with the photos. Now, this was also a difficult process. I'm hoping it's going to work, because it had to be photos of just that person. There couldn't be anyone else in the photo. So now that we've trained it, if we upload that same photo, we're going to see that it also recognizes Mike. I hope. There we go. Yes, it worked. Cool. Let's do one more photo. This one includes Rory. And I was going to do, and there we go, see, it does recognize all 4 of us. I was going to do a photo where I take a picture to prove to you that I'm not just putting pictures with blocks on the screen. And I'm hoping this will work, but it's a little bit dark, so I'm really hoping this will work. We tested it earlier when the lights were on, and it was working. There we go. So you can see it recognized their faces. Now, why am I showing you all of this? Well, I'm showing you that it works so that you will believe me when I show you the next part. All right. So I took another training set of data. I took the photos I had of Rory, and I went on the internet and looked for a few photos of Peter Dinklage. And I trained my data set, and I uploaded a test photo of Peter Dinklage, and it said it was Peter Dinklage. Fine, okay, that's fine. That's what is expected, right? Then I uploaded a photo of Rory. By the way, this is one of the ones I got off Facebook. And it says it's Rory. Fantastic, right? It's working. All right, but this is where things got weird. So I found this photo of Peter Dinklage where he really looked like Rory to me. And after this, no matter what I did, things were just weird. For example, so as I said, things got weird. I think I managed to confuse Azure. If I want you to take anything away from my little bit in this talk, it's three things. First and foremost, as developers, no matter how magical a piece of software may seem, we can break it. We can confuse it. With enough tinkering, we can make it do whatever we want it to do. Second, you don't need to be a mathematician who understands neural networks and machine learning in order to build cool stuff. And last, and very, very importantly, especially for those of you who are going to Rory's talk a little bit later, please remember that we have proven that Rory Preddy is Peter Dinklage. Thank you.
Thank you, Jerry. I did say plumber's butt. Once you've seen it, it cannot be unseen. All right, cool. For the last one, fact number 3. Now, I've been very vocal over the years about how passionate I am about this topic. You'll be amazed how much you can learn by just getting your hands dirty. There is ever with a person with the same amount of passion, but an advanced ability to explain this better. So please welcome to the stage a guy that refuses to wear shoes to work, our own Google developer expert, Mr. Michael Geyser.
Let me live up to expectations. So when Tony told me that I had to speak in the keynote, he made it abundantly clear that there was to be no code. It was going to be a high-level talk, which was fine. You know, I can do this. I'm sure I can. And then he told me I had to use PowerPoint, and my world shattered. For those of you that know me, you'll know that I really, 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 really like JavaScript. I'm that obnoxious guy that does all of his slides and presentations in JavaScript. But it's fine. It's fine. We understand the constraints and we move forward, right? So, I believe that there are 2 types of children. The first is the type that takes things apart to figure out how they work, usually discovering a whole bunch of spare parts in the process. Something I learned the hard way. Did you know that there's a little magic spring in every single toy that once it escapes, the toy ceases to function forever? The second type of child is to whom every found item is the start of a new creation. Every roll of paper toweling, every pretty stone, and every new pencil is the beginning of something precious, usually consigned to a big bin that never gets thrown away. The addition of googly eyes to any mundane item seems to turn it into a doll that's more desirable than anything store-bought. Now, why am I telling you this? Well, these children grow into adults, and these adults become programmers. Now, I know myself. I most certainly fall into the latter category. I catalog everything I find for potential later use as the potential seed for something new and exciting. But it's not necessarily as clean-cut as all that. And I feel that there's a little bit of both children in each of us. But this, and it's definitely not meant to pass a value judgment to those who identify in the former category. This talk, however, is specifically meant to encourage the explorers and creators in each of us. Now, what am I getting to? I believe we should build our own toys. Jerry's amazing computer vision demo was not our first foray into computer vision, despite its questionable training data. Our first attempt involved WebAssembly, HTML5, and a library called OpenCV. The results were interesting, a little bit disappointing, but ultimately very enlightening and paved the way to what you saw today. Rory later is going to explain to you his endeavors in natural language processing, and specifically his attempts at creating a pass-the-butter bot using Alexa. Now, as absolutely hilarious as watching him repeatedly shout, "Alexa, stop!" It was ultimately a failure, although he learnt a lot, right? And myself, my code folder is littered with half-complete web projects. I seem to try out new frameworks and features like underwear. A recent example comes to mind of a hybrid application that I built to showcase a friend's master's research. It was completed, and it was ultimately very successful after a fashion, but I was a little bit disappointed. It did, however, inform a lot of my thinking about hybrid applications in general and Ionic in specific, which I've used in my work environment. Now, what am I getting at? I believe we should build our own toys, because then you can explore with far greater freedom. You only really have yourself to disappoint, which is this weird facet of both having higher expectations but lower risks, and you're far more honest in your appraisal of what it is that you've built or worked with. Moving on from that, I believe we should build our own tools. Now, I know this is an unpopular opinion sometimes, but I don't think we should be afraid of them. I think it's the next step up on this free exploration, and it gives us something that has very clearly defined goals for things that are built for purpose. It's still a lower risk space, but with some very deliberate constraints. I think, honestly, that it's this confluence between constraint and freedom where real innovation happens. Now, thinking of an example from a few years ago, we had an automated test suite that was taking far too long to run, a sign of its success, to be sure. Now, we realized that there was a limit to how much we could improve this by scaling vertically on tin. So we decided to repurpose all of the build monitors and radiators around our floor and run Docker containers that each ran a subset of the problem and reported back to a central Selenium grid. Now, this increased the runtime by about an order of magnitude, which was great, but it took a lot longer to implement than we had hoped. And keeping it up and running was a lot more challenging than we expected. Now, this learning led to our first experiences with Kubernetes clusters. And we managed to go into that with our eyes open as to the challenges and opportunities that they present. Now, examples similar to this abound across BBD. Teams that have built build radiators and reporting tools using Angular have prepared themselves for new client projects. Building our own admin tools gave us a unique insight on OAuth 2 in the enterprise and Azure AD in specific. And test suites written in Scala dissuaded us from choosing Scala in new applications. And yes, I know what you're saying, and it's true. You will leave the littered corpses of half-completed projects behind you. And that's fine. Don't be afraid of it. Keep them as mementos, delete them, whatever, because what you learn from the process is what's important. The purpose of all of this is to be ready, to be able to seize the moment when it presents itself. Perhaps your half-completed application is going to inform your next platform upgrade. Perhaps your test suite written in a new language will help in an architecture discussion. Perhaps your Raspberry Pi-based CCTV system will help with the next distributed application. The AI in your game is going to help build the next decision engine. Machine learning on your logs to automatically identify a problem. Replacing passwords and biometrics with computer vision. What I am advocating is that you embrace change, that you explore freely, that you learn fearlessly, and that you play. Thank you.
Thank you, Michael. What an inspiration. Now, it's definitely been a blast standing up here in front of you today. I may just do this again. There's still time for a Mel Gibson moment. Okay, cool. Okay, so before I let you loose on the awesome speakers we have here today, I'd like to leave you with 3 thoughts. Number 1, think evolution, not revolution. Focus on what is important, not flashy and new. Because something changes, that allows something else to change, that allows something else to change. And you want to be part of the journey, not just the ride. Number 2, have a Dorothy Vaughan moment. When you sit in the next session or the next one, listen to the message. It is loud and clear. We have to fight to remain relevant. Dorothy was not going to be replaced. Imagine being a black lady in the early 1960s. Imagine having to fight your way into a library to get access to one book. Today, you've got access to everything. Have a Dorothy Vaughan moment. Think about what you need to change to remain relevant. And then finally, do something great. Yes, do something great. And saying this out loud makes it sound easy. And I can see some friends in the audience. But I truly believe it is that easy. The next time you sit in front of your computer and you've got 5 minutes to spare, like when you're famously waiting for that bowl to finish, read an interesting article. Read an article on something you don't know, something that touches your world, your livelihood, and then read another one. Yes, do something great. Consider what you have read and then start a conversation with the person next to you. Together, try it out, build something, play with it, master it. Because maybe, just maybe, you've created something great. But best of all, you've learned something new. I wish each and every one of you a fruitful industrial revolution. Thank you.